Starting chapter 1. We're actually starting geometry, which is exciting, I think. Geometry is a lot of vocabulary. We do a ton of vocabulary, and I hope that you learn to use the vocabulary, become friends with it. All right, I'm going to write my name on here, please. Please write your name on your notes. Okay. We have a little paper assignment today, because, again, today we're really just starting with vocabulary. We have points, lines, and planes that we're talking about today. A point is a location. It's how we identify a particular teeny tiny point. It has no size or shape. It is infinitely small. Okay, it's so small you can never really see it, but in order for us to be able to understand and do geometry, we have to be able to define these things. So we define a point. It's dimensionless is a good way to think about it. It has no width. It takes up zero space. It's crazy to think about how small that must be, right? Okay, infinitely small is a point, okay? But we have to define it somehow, and we always use a capital letter. This is really important that we all use the same notation. It's really kind of interesting. On my Facebook feed, I have different, groups, right, that you sort of get sucked into, and one of them is like a math girl. I'm such a nerd. I'm not really, but it's really interesting because we get a Facebook feeds from all the way across the Atlantic and the Middle East, or India, China, all these people, and the math is the same, and it's amazing. And we don't speak the same language, but the math is the same, and the notation is the same, and it's kind of fascinating. So we have these conventions that we all ascribe to so that we can understand each other. It is literally another language, and it's really kind of interesting. So here's an example. This is point A, and I could just write point A, but A is always going to be a capital letter. So anytime we have a point, it is always going to use a capital letter, and that is this point A here. Now, we also have lines, and you can see we have an example of our line here. A line is made up of points. 100 billion, million, trillion points are on this line right here, and you'll notice this line has arrows on either end. What do those arrows tell us? It goes on forever and ever and ever. And so you can imagine, if a point has no shape or size, it is dimensionless, okay? How many points are smashed together on this line that goes on forever? Is it just two? An infinite number of points, right? A line is made up of an infinite number of dimensionless points. It's crazy to think about, okay? Now, we have to define a line. It turns out that any 2 points will form a line. I can draw any 2 points, D and E, and if I can define 2 points, I can connect them and create a straight line. There's a straight line between any 2 points. Does that make sense to you? Anywhere in space, if I put a point here and I put a point here, can I connect them with a straight line? Yes, I totally can. All right. So, yeah. So it turns out that a line, because all of these points that come together to form a line have no real size, okay? A line has no thickness, and it doesn't, or width. It's just a line, but it's so skinny, it takes up no space. It's crazy, okay? we name a line by any 2 points on the line, or a lowercase script letter. So you can see in this example here, I could call this, I could write line in, so there's that little script in there, so we could define that as line in, and we might say that. I could say line X, Y, because those are my 2 points on my line. Do you suppose I could say line YX? Absolutely. It doesn't matter what order those 2 letters are in. That for a line, that doesn't matter. And I could also use notation, and this is what I would prefer you to do. X, Y are the 2 points on my line, are 2 points on the line. And we're going to use special notation. We're going to put a little line with arrows above. And this is very common notation, and we would read this as line XY. And so that notation with the arrows above is the notation for line. Okay, and that's how we would read it, line XY. So that is very special notation right there. I'm going to write it in red here. That is the word line. So we would actually say line XY. Could I do line YX? Is that fine as well? Absolutely, that's fine as well. Okay. Great. So we have a couple of vocabulary words here as well. We have collinear points, collinear points. When you look at that word, and I like to think about it as co-linear, okay? And the root of the word linear is line, okay? And co, work together, right? So these are points that work together to form a line. So collinear points are points that lie on the same line. Now, any 2 points are always going to form a line. So in order to have non-collinear points, we need to have, these would be points that are not on the same line, and it must be at least 3 points. So for instance, I could put on point Z right here. I could say X and Z are collinear. C-O-L-L, 2 L's. I-N-E-A-R. X and Z are collinear. Are they collinear? Yes. Can I draw a line between them? I surely can. Any 2 points. So I could draw a line between X and Z. There you go. I drew a line between point X and point Z. So they are collinear. But X, Y, and Z are non-collinear. Does that make sense to you? Because there are 3 points, they cannot be all on the same line. Well, they could be, but they are not. These are not. What if I put point A on here? Collinear? All right, so X, A, and Y now are collinear. Does that make sense to you? They're all in a line? Okay, great. A plane. So points, lines, and planes. So a plane is a flat surface made up of 100 billion, trillion, million, gazillion points. And we usually denote that plane using this sort of parallelogram-like shape. This plane is made up of any 3 points. Any 3 points that are not collinear make up a plane. Okay, So a plane extends indefinitely in all directions, which is a weird way to say it. It goes on forever. So even though my plane is drawn in this sort of parallelogram shape, we have to pretend that it does go on forever, left, right, up and down, okay? And it's important that we understand that planes exist in space. So this looks like a plane on paper, but, you know, our room is made up of planes. So we have the ceiling, that's a plane, and you can imagine that plane of the ceiling goes on forever and ever, okay? We have this plane that is the whiteboard behind me, and again, you can imagine that plane could go on forever and ever, okay? So planes extend indefinitely in all directions. We can name a plane by any three non-collinear points, or an uppercase script letter. So like they did here in this example, this is the uppercase script letter P. So we could call it plane P, and I don't know, maybe that's a script P there. I put a little curly tail on it there. Plane P. And we could also say plane, I'm going to go J, K, L. And again, these are capital letters that I'm using for those points, J, K, and L. These 3 points are not collinear, and that's very important. So we also have a couple of vocabulary words again. We have coplanar and non-coplanar. What do you suppose coplanar means? They're the coplane. They coordinate together on a plane. Points that lie on the same plane would be coplanar. And non-coplanar points are points that do not lie on the same plane. So for instance, I could put on a point here. I'm going to call it point Q. There. Look, I drew point Q on there. And what I'm drawing when I say point Q and I put it on there, and you'll notice I didn't draw it on our little picture of a plane. So what this is saying is I might have my plane right here, which is my hand, and point Q is down here below that plane, okay? So my hand might be the plane, and my point Q is over here, not exactly on the plane, all right? Below, maybe it's above, okay? But it's not on the plane because I didn't draw that point Q within my little plane boundary, okay? So we all have to just understand that. So point Q is a non-coplanar point. So Q. All right. Any questions so far? Pretty easy, right? Points, lines, and planes. All right. Intersecting lines and planes. 2 lines intersect at a point. Yes, a point. In this case, a point. What point are lines R and S intersecting at here? P, yeah. So I might write lines R and S intersect at point P. So 2 lines can intersect and form a single point. Now with planes, you can see here we've drawn a couple of planes. 2 planes, here we have plane L and plane M. 2 planes intersect and form a line. Yeah, you can see that intersection right here. They've formed line K, so they intersect and form a line. So we might say that plane M and plane L intersect at line K if we wanted to. All right. Any questions? No? All right, let's turn the page. And we're going to go through and just do a little bit of practice. We get out at 10:07. Hey, we're doing excellent here. Okay, so using this diagram at the right to name the following. We want to find 4 collinear points. What does that mean, collinear? On the same line. Very good. So give me 4 collinear points. So we want all 4 points. Yes. Shaylin. Yeah, right here. H, N, K, and I are 4 points all on the same line. So these would be 4 collinear points. So H, N, K, and I. And again, we're using capital letters. Very, very important. All right, a line that contains point M. What line contains point M? P. Yeah, we could say line P. P, there we go, line P. Is there another thing we could write instead of just line P? Oh, that's a good question. I don't really think we use the script letter with the line symbol, but we could do like, or you could say something like, MN. You could say line MN with the little line symbol above it. Could we say line NO? Sure. Could you say line MO? They are all describing the same exact line. So you could say either of those. All right, a line that contains points H and K. H and K. Give me a name for that line. HI, sure. We could say line HI, or what else could you say? Line R, yeah, line R. And right there is line R that has H and K on it. So again, there are multiple ways to answer. What is another name for line Q? LJ, line LJ. So we're going to use our line symbol, L and J with capital letters. Line LJ. Or, what else could you say instead of line LJ? KL, sure, line KL. Again, multiple ways, but capital letters, line symbol, that'll work. All right, the intersection of lines P and R. What is the intersection of line P and R? N, point N, with a capital letter. Very important. Again, it's a point, so we use a capital. Any questions on that? Pretty easy, yeah? Good? All right, let's look at 2. Use the diagram at the right to name the following. A line containing point F. J, line J. We could say line J. And we have other ways we could name that as well. We could say line DE, line DF. Okay. Another name for line K. BE, very good. Line, with the line symbol, line BE. Again, that's line K. Ooh, what's this mean? What's this dotted part here? What's that saying? Shaylin. Outside the plane. So what's really happening here, you can maybe imagine, is we have like a plane. This plane is floating in space. And what happened is this line, line K, is, I wrinkled my plane. That line K is passing through the plane, okay? And so this dotted line is saying that is underneath the plane. It's, you got to kind of imagine it's there, but then it pops out eventually because this line does go on forever. Does that make sense to you? Okay, so it's passing through the plane, coming out the other end. All right. So the line, give me a plane rather, containing point A. We could say plane M. Plane M. M. I don't know how you want to write. It should be a scripty kind of letter, but there we go. We could do it that way. Plane M. We could also name a plane using any 3 non-collinear letters. So we could say plane. What else could we say? Plane. So what are 3 letters in plane M? So J is not a point. J is a name of a line. ADF. Yeah, you could say plane ADF. A, D, and F are 3 non-collinear points that would also describe that same plane M. Okay? So 3 capital letters. Okay, an example of 3 non-collinear points. What are 3 non-collinear points? D, E, A. D, E, and A are 3 non-collinear points. Is there another? C, E, A. Very good. Yeah. C and E are part of one line, and A is not on the same line. So you might say C, E, A would also satisfy non-collinear. Okay. So lots of options here, lots of answers. The intersection of plane M is right here, and line K is right here. Intersect, where do they intersect at? E, point E. Very good, nice capital E, very good. All right. Example 3, number 3. We have this interesting figure here. You can imagine we have a plane. Again, this plane is going on forever in all directions there. And then sitting on top of the plane, we have a pyramid. This is called a square-base pyramid. And let's see. We want 3 coplanar. What does coplanar mean? On the same plane. So what are 3 coplanar points? Y, X, and V? Y, X, and V. Y, X, and V. Yeah, they are coplanar. Is that the only 3, or is there another 3? No, we could throw W in there. So W, X, Y, those are 3 coplanar. All right. What is a plane containing point X? Here's point X. Planar. That's the easy one. Put a little tail on there so it makes it scripty. All right. Plane R. All right. The intersection of plane R, so plane R, and plane ZVY. Ooh, interesting. ZVY. Plane ZVY is right here. It's sort of this sort of back left face of that pyramid. So that back left face right there and plane R, what do they intersect? Where do they touch? This part right here, this edge, which I just wrote over, which was a V. Okay, that was a V. Okay. So right here, this edge is where that back left face and the plane are touching. What can we call that? What type of figure is it? It's a line. And so we might say VY, line VY. Or, you know what she did? She put segment, which is kind of interesting, but that's okay. Could imagine it goes on forever. She put segment VY. I'm going to write that here. Segment VY, you'll notice it is just, what's missing on this little symbol? The little arrows, yeah. Which makes sense. It's just here on this paper right here. Either one of those I think is fine. How many planes? Ooh, tricky question. How many planes appear in this figure we see here? 5. How did you get 5? Woo! Yeah, the sides of the pyramid. Sure, we've got the base of the pyramid, which is resting on plane R. So that's one plane. But then we have 1, 2, 3, 4 faces of that pyramid. We got the front and the back and the left and the right sides of that pyramid. So there are 5 planes, okay? How many planes contain point W? 3, very good. Yes, point W is right here. It's part of the plane R, and it's also part of this right plane and this front side plane, okay, of the pyramid. So very good. With our last picture here, the intersection of lines L and line M is what? E, very good, point E. Another name for plane Q EGI, I heard plane EGI, very good, EGI, and I heard another one, IEF, was that the other one I heard? Yep, IEF would also work. Again, we want 3 points that are not collinear, so make sure they're kind of scattered. Are D and E points, are D and E collinear or coplanar? Collinear, yeah. You can see that we have 2 separate planes that D and E are part of, so they are not on the same plane. They're on the same line, however, line L. How many times do planes P and Q intersect? 0. They do not intersect. These appear to be parallel planes, okay? Something we'll talk more about. Do you have any questions for me? All right, sweet. You guys have a little quickie worksheet here to do.